Hello everyone, and welcome back to my channel. And I've been working on the prime number sieve Visual Basic script that I used to create a chart in a previous video showing how p numbers will block other p numbers from being prime. So this version of it will actually combine the rows into single rows. If you know from the previous video, the rows were split so that a 6n plus 1 and 6n minus 1 value were on two different rows, and that was necessary in order to come up with the correct formulas. However, I wanted to see what it was like if we put them together. And thankfully, since I was coloring the background, I was able to grab the value of the background and merge rows together. That also let me merge the entire thing together, so I've actually got a sort of a summary row. I call it result, and you'll see it once this runs. While I had mentioned in the previous video there was a lot of interesting patterns that popped out, there are also very interesting patterns that pop out in the new version that I'll have here as well. But to really show some of the patterns that are there, this needs to be a lot bigger. If you remember in the previous version, we had roughly 100 by 100 for our max width and max depth. I'm bumping it up to 6,000 by 6,000 on this one because we need to have at least 5,005 for me to be able to show one of the interesting patterns that will come about. So that means that this is going to take quite some time to run. Not that you guys will notice because I will edit, but let's get this started. Alright, that wasn't too bad after all. And as you can see, I've thrown in some statistics for what was going on here too. So over the course of 6,000 of these 6 to the n plus or minus 1 entries, there were 550 twin primes. Now, that's approximate because the last couple of columns might be inaccurate on this, just the way that it's going. So it's going to be about 550 twin primes. And of that, there would be 1,376 that were blocked by having a 6n plus 1 factor, and there were 1,347 blocked by 6n minus 1. There were also 2,727 where both were blocked, so there was no prime for that value. So again, this is just a little bit of quick statistics that are roughly correct within plus or minus 2 for each of them, I would assume. The first thing that jumps out is going to be where these are located. And you can see this pattern here on line 1, which is the representing 6n plus or minus 1, where n equals 1. So we're talking about 5 and 7. Now 5 and 7 multiply together to make 35, which is right here in between. And that brings up an interesting point. You know, if you've watched the previous video, we have this initial skip that happens at the front of the line for each row. That initial skip actually is hiding where the pattern begins. So the pattern actually begins with one of these at the very, very front. But that is actually representing where 5 times 1 is a value and where 7 times 1 is a value. So we don't want that to actually show up on here, because if we showed it for everything, it would just create a solid line going down this diagonal, and everything would show as if there were no prime numbers. So for the graph, we skip that, but the pattern actually begins right here at the beginning. So we can actually think of it as starting here, because this is where it repeats. So it goes from 36 to 70 on here. And we know that's the case because 7 times 5 is 35. So it's going to be repeating every 35. This is what happens when you have a sequence that has a period of 5 and a sequence that has a period of 7. To have both of them repeat, you have to multiply those two together. Now, what's interesting is if we just scroll out here a ways, and I want to be on the second line, as we come out, we can see here's another one. And in this case, up here you can see where the 5 and 7 are repeating their pattern. This pattern is expanded out. So instead of just having 1, there is now 3. And if we look right here, we can see this is 143, where this repeats. And what is 143? It is 11 times 13. And that is what the n, when n equals 2, 6n plus or minus 1 is 11 times 13. And that's going to repeat here. With that in mind, you can kind of already know what the next one is going to be as we scroll over here. Here it is. Now it's got 5 in between, and the middle is 323, which is, of course, exactly what 17 times 19 is. So this is how patterns repeat. And again, they're repeating in this manner because each one is a prime number, each one is different, and therefore to find how the patterns combine together, you have to multiply them together. Now, let me pull over a calculator really quick. This is what you get when you multiply 5 times 7 times 11 times 13, 5,005. And what that means on here is that the pattern of all of these, if we go back to the beginning, these two, only the first two rows combined together is going to repeat at square 5005. So we can search for 5005 because we put in the values. Right here is where that repeat's going to happen. And you'll notice once again, it's right in between where these blue ones are, the dark blue. And the dark blue is where both prime numbers are blocked from being there. If you look here, this is exactly what would happen. So remember, if this is square 1 on here, we have an initial skip, but this time we're not skipping it. Then you're going to have the 2 with this one being the plus 6n plus 1 block, and then a skip 1, 6n minus 1 block. Then this appears on the second one, so it does have the initial skip. We always skip that first one, not counting the very first row. It will be skipping, and as I said, it would make that diagonal down like this. The second time the pattern repeats, it is going to show that going down that way. And then we'll have that initial gap, and if you can see this little 4 cluster here is going to be exactly what you see here. That little 4 cluster there. And if you just imagine the other two in here with dark blue, which again, like I said, we can't put it in because it would make everything the dark blue when we combine everything together. And of course, that's not accurate. So that is part of the internal structure of what's going on with this. That's just one of the interesting patterns that I saw on there. Patterns will always begin with these prime blockers. And the more and more that we get together, then as once again, if we go back to this square, if we get enough of these patterns repeating, then that's going to block prime numbers from existing for as long as this goes down. And of course, the number where that will occur at is huge, but notice that it will go this way and it will go that way. So it'll block for both sides of this pivot point, leaving that pivot point open for having potentially prime numbers. Although, as you can see here, this one was blocked by this point and possibly more later down. So this isn't a double prime. And there could be other parts of the pattern that will block this. But interestingly enough, even though we're this far down into the pattern, we still have double primes here, and we have them here. Here's another one, and another one here. Double primes, while they do seem to get rarer the longer you go, the conjecture that there's an infinite number of them, which has not yet been proven, does have a lot going for it. Now, people have calculated far beyond what my little graph has shown. So we already know up to this point that there are far more twin primes than what are just available on this particular graph. But once again, this is very similar to the way that the factor field in general is working. One of the other patterns that I did want to point out before I forget is we have this where we start with 2, where you have the 6n plus 1 and then 6n minus 1. Then that's going to repeat down here and here and here. And we get this line that just is consistently going down. And then it repeats up here for these values as well. And let me click down on here. If we scroll over, then you can see that there's more of those where we have like this pattern repeating as it goes down. And we'll keep scrolling for a bit because you can see these other patterns that keep appearing very, very regularly throughout. In fact, let's just go to the end here. I forgot, because of how there's a bias towards the width, because the height grows very slowly, whereas the width grows very fast in this. So I think we're at the end on the width. Yes, we are. So we can just scroll down like this. So we got that, and then this is going to be spread out a ways. But you can kind of see how these lines do exist here. They're more and more spread out. I'm scrolling down further and further. It's going to take a while to get to the, there we go, with the 2. And I believe there should be one more that has the 2, and it's going to be pretty far down, and there we go. So these patterns are throughout the entire thing. Once again, this shows how chaotic things can be. So it's kind of like when you have a bunch of patterns that don't quite line up with each other and you're putting them all together, it kind of makes dissonance if it's a sound wave, for example, because the waves are going to be crashing with each other. Sometimes peaks will level out, sometimes they'll become huge. So you get dissonance through it. And the dissonance is kind of like random noise. You can think of it that way. This is the same thing that's happening with numbers in general, specifically here with the primes. But this is inherent to the number line as a whole. It happens with the vector field. It happens here with prime numbers. And it makes sense. You can break it into individual parts and you can see the individual patterns and realize how the individual patterns are all strictly determined. There's no way you can not guess that these are going to continue in the way that they're going. And even when you look at line by line, the patterns repeat. And we saw in the previous video the formulas for how those patterns repeat. And those repeating patterns go forever. But because they're just barely different from each other and they're expanding as you go down the chart, and so each time they're just slightly different than the previous versions of it, then you end up never actually repeating exactly what you had before, because there's enough differences that it, for lack of a better term here, corrupts what would have been a quote-unquote perfect repetition by adding in noise. It adds in that chaos that makes it unpredictable. And in fact, it's not just unpredictable by what we've got now, it's unpredictable forever, unless somebody can come up with a better theory of chaos. In this, we have subtle differences that we know what the differences are because we can calculate them. But as soon as you start heading to the right down this list, trying to figure out what this summary line here is going to be, like if I stop right here and you can see all of this coming up, do you know right now, without calculating every single row, what the next square is going to be? I can't figure it out. I have to actually look. So yeah, that's just part of the problem that we're going with. One other thing I was just reminded of too, when you see here we got 2 twin primes in a row. And I wanted to point out that because of the way that the 5 and 7 line work, 5 line in particular, there will never be more than 2 twin primes in a row, other than the very first one where we have 3. So we start with 3, but then this pattern that repeats guarantees you can't have more than 2, because on this line here, line 1, row 1, the maximum it has is 2. So even though you can have tons of space down here, you're limited by this up here. So from this point on, after the initial 3, the maximum you can ever get is 2. So there can be back-to-back twin primes. They're going to be fairly rare because it's got to hit into the gaps for everything going down. And of course, you can see it here and you can see it here. But the more that you add in, the more of a chance for things further down to block. And the more common you're going to get where everything is blocked. So anyway, I thought that this was another interesting thing to look at, and I hope you do as well. If you do enjoy this type of video, feel free to hit the like button and subscribe if you haven't already. And you guys have a wonderful day. Peace out.